Okay, my friends, I am always bragging about going to this school and that school, which I do. I go through Coursera. It's free. This University of Tokyo and UC Berkeley, Lawrence Livermore, Berkeley Labs. This is their physics and mathematical department at the University of Tokyo. Very advanced stuff. And this is about from the Big Bang to dark energy. And they starts right off by saying they were completely wrong about everything they thought. Right, here it is right here. It says, what we used to think we knew about the universe is now totally wrong and outdated. Absolutely. But then he goes on to talk about space being a vacuum. And we all know now that it's not a vacuum. So I put up this. There's one of the learners, they call them, the students. It says, can we see any of these effects of the expansion of the universe? Because that's what we're talking about, is expanding space. And they say it's expanding. We know it's expanding because redshift. Light is slowing down. Well, light's slowing down because it's coming through the non-vacuum of space. So here's what I wrote. I said space is loaded with particles. Light slows down. There is no vacuum. And this is from the government. From Fermilab says absolutely. Well, here it is right here. Empty space isn't empty. It's saturated with particles. That goes back almost 10 years. They know that. They say empty space experiences subatomic particles winking in and out of existence. And they're all over the universe, and they have a measurable impact. And they just, don't worry about that, forget about that, just sweep that under the carpet. No, absolutely not. The light is slowing down as it comes to us. So I put up this post about this, and here's how they answered it. Here was the answer. Well, we know it's slowing down because of this. Well, we know the universe is expanding because of this nonsense. And then, of course, I wrote again. I said, no, it's empty space isn't empty. Don Lincoln at Fermilab. All right, if it's true that empty space isn't empty, light has to slow down. Am I correct or not? Of course, there's no more responses to that. At first, I was very well received, and then that stopped very quickly. You see this? This is what I showed University of Geneva, which is right over there at CERN. We focused and we exploded the particles. Exactly what they were hoping to do is to create sterile muons and electron showers. The black ones are sterile muons. These are the electron showers. This is what we did, and this is CERN, or Fermilab. Both of them have the same thing. They found these two the black and the red particle. We did too, only we could see them much better than they could. They could just see them in a pile of debris, but they know these are the smallest particles. We see them as attached to each other as parts of light. The dark matter is right there. Nobody's ever known it before because it's part of light. All you see is the light. You don't see the dark. That's why everything has weight. Otherwise, it wouldn't weigh anything. If all you had was this particle here, that has no weight. And they know this at Fermilab. They're fully aware of this. There's no weight, and the black one is all the weight and no burn. This is all the burn and no weight. These are the particles they found. I told CERN about this. I called Fermilab too. They won't talk to me either. You know, they want to work with protons. That's fine. But these were where they want to get to is these particles. We were already there. You see this? This is what they want. They want these muon neutrinos to come into a sterile muon, and they want the electron neutrino. Normally they were attached, called Dirac. And they want that to shower away and become an electron shower. This is fission when they break, and when they come back together, it's fusion. We did exactly this. It's exactly what we did. We broke them apart there. The black separated from the white electron shower. They come back over here, and they fuse back together. That is the holy grail of energy. Nobody will speak to us. Not a single one. Rod Warren is the one that developed this just by accident. I took over as because I'm, you know, that's what I do, is physics and so forth. And Rod did over and over for years, worked with me showing that this is light, and these are the particles of light. And not only that, we can separate the light. There's the heavy part and a glowy part. That's all there is. And again, these are the kind of people that they refuse to discuss anything with anybody so that they can keep their funding and keep their own status. And the same thing's going to happen here in this biology. I know that's going to be a fact. This is a Hadron Collider restarted. And here's what it did. It said improvements in the injector complex. That's to make them, so now they get all kind of better collisions. That's what before they were just going by and hoping something hit. Now they're focusing them back together, head to head, and they're getting a lot of more energetic reactions, but it's still just nothing but debris. We're actually tracking the light and watching them separate, and the neutrinos gain value and lose value. We're doing all the things they wish they could do. And because of the money and the investment they have, they refuse to discuss things. I found that in 100% of academia. Okay, my friends, get ready. I am going to make some outrageous claims, and I want somebody from Fermilab or CERN or the government or someone to say, no, Roger, you're not right. You're saying things that aren't true. I would love to have that happen. They won't respond because they know they are true. I have upended every single one of them with my research. We found these particles, and I can show them in much greater detail than CERN or Fermilab. These are the kind of statements I'm going to make that are going to sound outrageous, and they are true, and you'll see the truth that they are true. Empty space isn't empty, and still they think that light is going through a vacuum. Well, empty space isn't empty. Fermilab agrees. Almost 10 years ago, I had worked with all of these people, and they refused to engage because they know they're wrong. Once they were engaging, they started, oh, Roger, let's talk. As soon as I showed them, shut right off. Same thing happened just recently with the University of Tokyo. I'm taking a course there. I think it's right over here. This is it. It's just it's called the Big Bang. Hold on. From the Big Bang to dark energy. And it's totally wrong. Absolutely totally wrong. The first thing I said in the comments, because I go there to sort of start trouble. The first thing I said was, if space is filled with dust, how could you possibly say light isn't slowing down? And the only response I got was, good question. And then I got a whole bunch of nonsense, which is this stuff here. Well, here's how we know that light, this is how we know the universe is expanding, because of these numbers. It's totally ridiculous. And after that, there's no more responses. And I said, no, empty space isn't empty. Don Lincoln at Fermilab says it isn't empty. So light must slow down, therefore there's the redshift. If this statement from Fermilab is true, light will slow down, correct? No more response. Forget about this guy. Don't talk to him. I'm a learner. I have to learn to say what they tell me to say. Well, I don't learn that well. See, this is the CMOS sensors, development of high voltage CMOS sensors. Well, the high voltage, the problem is they're using protons, which have big chunks in them. We're using light, which has a very small chunks. Light is what CMOS is there to detect. This luminosity is light. So here they're upgrading, they're doing all kinds of stuff to upgrade CMOS detectors, system development, Large Hadron Collider, undergo a major upgrade so they can use the CMOS. Exactly what I told them. Focus and use CMOS, you'll see the same particles we see. And they do, but only they see them in debris. We see them actually manifest themselves. Okay, so I know it sounds incredibly arrogant to be making these claims, but they are true, and if they're true, it ain't bragging. This is what they see at CERN and Fermilab. They see balls of garbage, literally garbage. This is something you should take out to the trash. And they're looking through there to try to find the smallest particles that exist, and they find them. Big deal. So they see them, and it means nothing what it means to us. Look at what they find here. This is the big deal. So, this, big deal. It means absolutely nothing. What we did was we took light right here from a pulsed red laser. Let me dust my screen off a little bit. And as that light came through, we see them as neutrinos. They're not even photons yet. then they turn into actual looking photons and back into some other type of neutrino, and then they split over here. This is the elegance we can see it with. We don't see just trash. I could show you some trash, but it's elegant trash. There's our elegant trash. This is the white shower of electrons, the white electron shower I showed you in their particle doodle they show. This is it, and then it creates all these Higgs fields. This is exactly what they were hoping to see, only we can see it. They can't. All they see is this trash. That's what they see. And this is just a doodle. They really can't show you much other than just a bunch of squiggly stuff. And then they pick through it, and they said they had 1,000 guys or something looking through it for 4 years to try to find the particles. We could find them thousands and millions of them in 20 seconds. This is what we did. We accelerated the light. The problem is what they're doing. We are capturing and detecting the luminosity. They are creating the luminosity by these explosions. They're just making huge explosions. We're seeing what's coming off. And it's making its own explosion through this Venturi. That's the separation. So, again, I know it sounds arrogant as hell, and I'm done being polite about this because I was hoping they'd take over. But no, absolutely not. They don't want anything to do with this reality. They just want to stick in a fantasy land where there's tons of money. I want to see where we can get some free energy from this. And I think we can by hitting this Venturi right here. Hold on, I got a little drawing here that I made. All right, look at that Venturi. When you see luminosity like this, you send me one physicist that tells me that did not increase energy from here to here. That is increased energy, zero question about it, none. What we did, and I'm talking about a lot of extra energy, what we used was a pulsed red laser, or in this case red, we could use green, blue, whatever. And the black particles are the big heavy particles. They can't get through the restriction, so we created showers, the white showers. If we could pick up those showers here, those are extremely energetic. Whenever you see glow, that means energy. This is energy. What we use it for is up to us. It's coming out of here in the form of electrons, literally electrons. We don't have to turn it into turbines or anything. We just take those electrons, pump them right down through a diode, which is nothing more than a gate. It lets in and the gate closes. You can't get back out. Pulse, 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 pulse red laser. Every time it slams this, it's like a toothpaste tooth. Squirts down here. It has to go somewhere. And you put diodes in here, and they'll force it to go in here. It can't come back. You charge your batteries, you use the electricity. That's called free electricity. And that's what I am trying to produce, or at least have somebody look into doing, and it's refused by Fermilab for years and years and years. And we can see the particles. We can see green is the exact same particle, no difference whatsoever. And these are the neutrinos of the green as it turns into a photon. All right, so there's very little to dispute here. These are the same particles right here. Only these are the red, and these are neutrino values of the particle itself. The only reason this particle is showing up so well is because it's directly in line with the Venturi. If it's not directly in line, you don't get that reaction. You see here? This one wave, they're all over the place here. You see them here? They are? You don't see them. You're never going to see that. The only reason you see these here is because it's pushing back against them from these reverse concussions. These waves come back out here, way back here. They're reverse against these light particles. The light particles are coming this way, but you never see them. In the air, you don't see light in the air. It just goes through the air. But we're seeing it here in the air because it's forcing itself against the rest of the particles and creating energy. And here it's starting to really create energy. And then up here it's really starting to show its own particle nature. And here it just explodes because the white cannot, the white can get through and the black cannot. and then over here it starts to recombine. This is a single slit. This has nothing to do with double flapping waves. This is one single slit, and it's forcing that particle to pull itself right out of the wave and break. We broke light. All right, that's just the way it is, my friends. And they will not respond because of the way science works. It's a totally broken system now, 100% broken in every range, every area, biology too. And that's the one I don't know if I mentioned it, but I'm going to be taking a course about biology everywhere. Now, I don't know if they realize how much biology everywhere really means, but we're going to find out. Just one last time to wrap it up. That's the particles CERN and Fermilab see in those big balls of debris. And they say these are the smallest things we can find. But then we find a whole bunch of other ones we see all the time. All it means is there's 4 or 6 or 8 of them together, and they sort of hang together pretty tight. So they figure that's also an elemental particle. It is not. These are the only elemental particles that exist. They normally exist as a pair, but we see they can be separated, no question whatsoever. Light is this particle right here. And it comes in neutrino value as it starts to stack up against itself and create more and more energy. These particles change in values. That's why they say it's like ice cream. You just buy it at the store and it's chocolate. On the way home it turns into vanilla, pistachio, whatever. By the time you get home it's tutti frutti, who knows. The same thing with this. It keeps changing its value as it concusses against itself. As I showed you. This is not something I didn't show. And I showed the particles they're looking for, and we created them. Refusal to discuss. Okay, I know I'm making outrageous statements, but I'm going to back them up with evidence. Now, this goes back a few weeks ago. This is a Nomad report. And they're going to show about CERN and about the new developments there. And I'm just going to let this run, and you pay attention, and then I will make my statements about their statements.
Using thousands of magnets, various types and sizes. These include 392 quadrupole magnets that each have a length of 5 to 7 meters, and 1,232 dipole magnets that have a length of 15 meters, and bend the beams respectively. Another kind of magnet is employed to squeeze particles closer together just before the collision is set to happen to boost the likelihood of collisions. The difficulty of getting particles to collide is comparable to precisely firing 2 needles 10 kilometers apart until they meet halfway. Around 4 collision zones, 7 gigantic detectors, roughly equivalent to cathedral-sized digital cameras, have been erected to collect data on these exceedingly uncommon particles as they flash briefly into existence. Furthermore, the 1954's founded CERN laboratory is located close to Geneva, directly on the Swiss-French border. It is one of the first unions in Europe, and it has 23 members. And today, over 10,000 scientists from over 100 different nations visit CERN every year to use its facilities, which include some of the largest and most sophisticated scientific instruments ever made. Their objective is to ascertain the materials that make up the very universe we walk around in, and the physical principles that govern that behavior. Anti-hydrogen, which is the antimatter equivalent of hydrogen, was first made by CERN researchers in 1995. Quark gluon plasma, a hot, dense particle soup, was discovered in the year 2000. Additionally, the Large Hadron Collider at CERN saw the Higgs boson for the first time in 2012, earning its discoverers the Nobel Prize. Now, talking about LHC. LHC is the most potent particle accelerator in existence. Physicists use this enormous machine to collide tiny subatomic particles at extremely high speeds to observe what happens. The conditions that existed right after the Big Bang, when the universe was created, are briefly recreated by particle collisions. Physics researchers strive to answer questions about the composition of matter and how particles acquire mass by examining the debris left by these encounters. Experts are hoping to uncover new information on the underlying components of the cosmos as the Large Hadron Collider, a massive proton smasher at CERN, prepares to begin its third round of data collection. As we've said earlier, over the past few years, CERN physicists have identified a large number of novel, unusual particles formed in collisions caused by the Large Hadron Collider. Or hadron, whatever. To assist in posing some order on the expanding particle zoo, the team, which has identified 59 out of the 66 most recent particles, has developed a new naming method in response to the sheer number of new particles that have been discovered. Let's go back to the discovery again. A new kind of pentaquark and the first ever pair of tetraquarks, which contain a new kind of tetraquark, have been spotted by the worldwide LHCb collaboration of the Large Hadron Collider. The discoveries, which were made at a CERN conference, bring the total number of new, unusual hadrons discovered at the LHC to an ever-growing number of 3. They will aid scientists in comprehending how quarks combine to form these composite particles. So basically, the quarks are the basic building components of matter, to put it simply. They are often located inside protons and neutrons, which are the fundamental building blocks of every atom in the universe. The quark particles typically combine to form hadrons, such as protons and neutrons that make up atomic nuclei in groups of 2 and 3. Tetraquarks and pentaquarks, also known as 4 and 5 quark particles, respectively, can also form their combination, albeit less frequently. Around 6 decades ago, physicists...
Okay, my friends, this is what I've always said the proton is made of, is all there is those 2 little black and white particles, which make up a gluon, and 1,823 of them make up a proton. 1,824 is a neutron because it has an even number. Now, they're going to be talking about the new research and this terrifying discovery here at CERN.
At CERN, the equipment is made specifically for particle accelerators and detectors. Particle beams are given a high-energy boost by accelerators before being made to collide with other beams or its...
And this is what I was showing them at CERN, at Geneva, Switzerland there, this to focus in, and they eventually did that. And then I said the other thing is, you're picking up radiation. You don't want to interfere with these particles by putting in magnetic sensors, and which is what they did. They call it the observer effect. Well, the reason it's the observer effect is that they're affecting those particles because they are magnetic particles. You put a magnetic sensor in there and they're going to go this way or that way away from it. So they put it in there and all of a sudden something changes. They go, oh, if you look at it, it changes. No, if you look at it and look at the luminosity, if you detect it, that's fine. If you interact with it, that is not fine. We detect using CMOS, and that is exactly what they're doing now too. And it's working for them.
Stationary targets. Detectors keep track of and log the...
Remember, this is what they're looking at. Is this particle coming this way, this particle coming this way, and then just a smash of debris, and then they're digging through it to find whatever the tiniest little bits are. And then they get all excited. Wow, well, look at this one. And then I think they got like 60-something new particles they've discovered because they're not new particles. They're just, instead of being one of these, there are 3 of them. Or there's 12 of them. Or there's a ring of them instead of a square of them, or you understand what I'm saying? They're seeing the same particles, but in different quantities. That's all it is. In different states of energy. All right, just listen to this for a minute or two.
To collide tiny subatomic particles at extremely high speeds to observe what happens. The conditions that existed right after the Big Bang, when the universe was created, are briefly recreated by particle collisions. Physics researchers strive to answer questions about the composition of matter and how particles acquire mass by examining the debris left by these encounters. Experts are hoping to uncover new information on the underlying components of the cosmos as the Large Hadron Collider, a massive proton smasher at CERN, prepares to begin its 3rd round of data collection. As we've said earlier, over the past few years, CERN physicists have identified a large number of novel, unusual particles formed in collisions caused by the Large Hadron Collider. Or hadron, I'm sorry, whatever. To assist in posing some order on the expanding particle zoo, the team, which has identified 59 out of the 66 most recent particles...
Did you hear that? They've examined 59 out of 66 recent particles, something like that. But look at what they're looking through.
To assist in posing some order on the expanding particle zoo, the team, which has...
All right. Here's what's happening. They're coming, boom, and all this stuff goes flying every which direction, everywhere. What we're doing is we're taking one particle, basically the light particle, through the accelerator and seeing what comes out the other side. This is what they're doing. Remember what you're seeing here. All these different colors represent different energy levels. That's what a different color is. And I can show you in our light research as well. I can show you the green is much more energetic than the red, and the blue is much more energetic than the green. And it all relates to how close that particle is to the core. If it's right next to the core, it comes out blue because it's really got to be pulled out hard. If it's way out here, it comes out red because you just bounce it away and it goes away. In the middle, it's green because it's got to be pushed pretty hard. And that will push the red out of the way. So don't forget, this is what they're seeing. Let me show you what we're seeing. All right, this gives you a real quick overview of everything. That's just pulsed red laser coming through the air. These little particles here are nothing more than gases that are in the air. They also have magnetic polarities, so this pushes against these. These glow a little bit and just get out of the way, and this really has to plow through. Now, this is the acceleration phase through the Venturi. The Venturi is down here. Now, at the outside here, you get your Higgs fields. That's when this white spray comes out this way and incorporates with the black particles that will be right out here and turns into Higgs fields. This is the particle. This one is the red. I think I've shown you the red and green and maybe probably the blue. But anyway, that's what they are. And that's what happens to them as they come forward. These are neutrinos. These haven't got the same value as the photon yet because they're not concussing directly in line. They're not directly in line. They're over in here. They're going to get concussed back at because of the reverse EMF. And that reverse EMF comes back. Normally it goes forward, but when you concuss like this, you get that reverberation backwards. So I'm just going to point out here and there, and just so you understand. We accelerated that light. I showed you that. We split that light from the black to the white, which is fission and fusion. This is the particle. This is the phases of neutrinos, and then photon, and then the sterile muon and the electron showers. This is Higgs fields after the electron showers reignite or reincorporate with the dark matter. This is what they're seeing at CERN, trying to dig through and find these particles that we found. These two particles, that's what they look for. And they found them. They found them, but they're just in a pile of trash. We can see them right here in our light. We started with light, so we don't have to dig through anything. We dig through nothing. All we have is light, and light itself turns into the same particles as I just showed you. These particles right here. And these particles right here. It's what they've been trying to do. We did it. They refused to discuss. I don't think that's right. All right, I'm going to just tell you something that's stunning for sure. What dust from space tells us about ourselves? It tells me that we're idiots. Our particles in our atmosphere are scrubbing through all of the particles that are in space. That's what causes the enormous increase in temperature out at our outer limits out there. It's like 2,000 degrees. Seriously, where our atmosphere scrubs. Saturated with dust. That means that Hubble is not seeing things shift away. It means that the light is slowing down. They think everything's expanding because there's just nothing in space. They know that space is saturated, and they have known this for a very, very long time. Since 2012, empty space isn't empty. It's completely saturated with these particles, which are subatomic light particles and dust winking in and out of existence as they get bombarded with other particles, slowing those light particles down. That's why we're seeing the redshift. Anytime you see all that stuff, it's the clouds of dust. They know this. They've been talking about it forever. They still just, let's forget about that. Don't ever talk about it when we talk about Hubble. Just think it's just nothing out there. And we know just how far that is because the light has taken, 6 million light years to get to us, whatever. What if it's going through something dense? Obviously, it's going to slow down more than if it's going through something sparse. So we have no idea where we are, none whatsoever. We're totally lost in space. And the reason you have these dark regions between the light regions is push to shove. You end up with getting a no man's zone in between, which is literally dark matter. And it all comes wrapping around in the center, and all that dark matter gets plugged into the center, and then all that stuff glows because it wants so hard to get in at that dark matter. That's what a black hole is. It's just a glowing ball of stuff wants to get in to all that dark matter. It's so attractive. That's the key. All right, I'm going to help NASA a little bit here too. The sun is moving in that direction. This is a solar eclipse. The moon is here shielding the sun so we don't get blinded by the light, but we can see all the particles radiating out. Light, as I have shown you or will, is a particle. This, and this are the most concussive zones, and they separate each other out by these magnetic fields because the sun is spinning this direction. That gives us the poles up and down of the sun. And this is where it's interacting most violently, creating this energetic reaction. This side is the trailing edge. So this side is going this way, and the sun is moving that way. It's spinning, so both of these would be the same, and they're not if it wasn't moving. It's moving in that direction. These are hitting harder as the sun spins in this direction. This is the trailing edge. So all of these particles and dust and debris is spinning out into space, and it will go somewhere. It's not just stopping. It's going to be out here just everywhere. It's very energetic here, but then by the time it gets out here, you don't see it anymore because it's not winking in and out of existence like they said at Fermilab. It will. If you looked at it very carefully, you would see it. And John Glenn reported this was the first time they went into orbit. He went out and he said, as I look into the darkness of space, I can see all the particles flashing in and out, millions of them. They are winking in and out. And guess how much the temperature is out here where we scrub? It's over 2,000 degrees. You know, on Earth. Well, I'll show you in a second. But on the sun, it's millions of degrees out here where it scrubs. This scrub zone out here. Millions of degrees. On the surface of the sun, it's only 10,000 degrees. Why would it be millions out here? It's because it's scrubbing through as it's plowing forward like that. See, this gives you a little better idea. Out in space, they're finding all kinds of particles. They're even finding water moisture particles out here. All they are is these pieces of particles bonding together when they can get in the right areas in the right places. You could have water out here, you could have anything. We're scrubbing like crazy with the atmosphere out here, which they don't think, they say, oh, there's no vacuum. There is a vacuum out there. No, there is not a vacuum. Everybody knows that now. We're scrubbing through that. That's where the zone of scrub comes from. Thousands of degrees out here. That's radiating down, heating us up. And the reason it's getting more and more tumultuous on Earth is either we're coming into a more dense region of space that is more reactive to our atmosphere. That's one possibility. We're scrubbing harder through a denser region. That would make more turmoil out here. Or our planet atmosphere is expanding from the combustion and all the energetic things we do that turn solid things into gases. What is that going to do? It's going to blow this up. Gases blow up like a balloon. What's going to happen? This is going to be out here instead of down here. What does that mean? Tremendous scrub. Hurricanes, tornadoes, floods, lightning, all kinds of hazards, weather patterns shifting because it's more a scrub now. And that's what's going on. And they don't even pay no attention to that whatsoever. Like it's just not even there. And when you bring it up, not another word about it. And I just did. I think I've maybe told you. I'm taking a course right now. Dark matter, the Big Bang to dark matter, which just goes through this whole thing. And the first thing I asked, how can you say that Hubble and all this stuff is working when there's all these dust and gases and things obstructing that light? The light is slowing down. Whew. Dead silence. Dead silence. And they're the ones professing. All right, so let's get reality going on here and have a little discussion about this because it's just nonsense now. It's dictated to say, tell me what I tell you to say, and you'll get a piece of paper. You don't tell you what I say, you'll be considered an idiot, no paper for you, and we keep your money. How about that? So what do you do? What would you do? What would you do? You do what you told us to do. You'll sit in a corner, read page 27. repeat it, get your grade, and go out and everybody will think you're a genius, especially if you paid a ton of money, like to Yale or somebody like that. And in my experience with Yale, in my opinion, there's no concern for reality there whatsoever. Or any of the Ivy League schools, because I tried them all. I went to only the big, well, no, I went to all of them, really. Even the community college, they won't, then nobody will talk. They're afraid to because of their peers. It's become a racketeering job for the thing, and it's in collusion, and they're working against the student in their own interest. That's fiduciary obligation, is for them to be a fiduciary to the student because they're in a superior position, and they're supposed to be trying to get that person to be more productive in their life and more, earn more money and all that. That's what a fiduciary does. They act in the best interest of the person that they're helping. In this case, they're helping themselves. And that's all I've seen in academia or the government. This will go on totally on, I've been talking about this since 2015. I put up videos saying dark energy and dark matter is light in coming through to Earth. I forget what I titled it, but I did show it, all this stuff. I've shown all the other stuff I'm talking about. I'm showing the light. I'm showing the particles they want to see. Here's Don Lincoln's particles right there from Fermilab. Those are the particles, and there they are. They do exactly what he says they do. And the light is, the universe is saturated with particles, so how could they possibly rely on Hubble? This is just complete nonsense now. And there's no appetite for the truth. That is the truth. Okay, I just showed you what we're paying the bill for. Now, this is NASA's fiscal year 2024 budget. Listen to this.
Cabana for opening remarks.
Well, good afternoon, everyone. As Catherine said, I'm Bob Cabana, and I am really pleased to introduce the President's FY 2024 budget request for NASA. NASA's budget request is $27.2 billion, which is a 7.1% increase over the agency's 2023 enacted appropriations.
All right, did you hear that? Billions and billions of dollars. They don't even understand what's in space. And they've been doing this for many, many, many billions and billions of dollar years. I think I should be able to speak to these people. They won't speak to me. I can show, even a 10-year-old understands the particles in space is saturated with them. And they're trying to come up with all these proposals about how to handle global warming and everything. Well, global warming is the scrub. Let's look at that instead of trying to figure out how to sequester carbon. That is just a total, complete, absolute nonsense. It's like they say there's a blanket around the Earth. Well, there's somewhat, but that's not what it is. It's the scrub. It's 2,000 degrees out there. Why? Tell me. Have anybody explain that to me other than they say, well, that's where all the particles of light hit. Yeah, what are they? They're particles. They're particles. A particle is a particle. Something bumps against it, it bumps back. It slows the other particle down. It's as simple as that. A 10-year-old, 5-year-old could understand this. All right, what I showed you, I think I did show you that we can accelerate light, we can split the light. We should be able to harvest that energy through a device as simple as this in something as small as this, and be able to put out any kind of electricity we want. Just have plugs coming out of it. Have a little selector says I want 50 cycle, 60 cycle, 120, 240, whatever you want. AC, DC, USB, but whatever. Carry them in disaster zones. If what I'm showing of our light research works, and they want to drill huge oil drilling in Alaska, they should have learned from what the Russians learned. I spoke to the Russians back in 2014 or 2015 about their sinkhole problems, and we're going to have just as bad or worse. You take stuff out of the ground, the tundra will collapse. I've tried to show everybody, I've tried to contact everybody that's involved in the government and the top universities about this accelerating light, creating fission and fusion, and if we can do that, we should be able to create free energy. They have this new thin film solar receiving panels now that they're making with these thin films, very cheap, very easy, and they're just different layers of metals that will absorb all that energy straight down through a diode, because this is going to be pulsing. It's a pulse laser. Bam, bam, bam. Every slap is a squirt. That squirt will go down through a diode, which is a gate. Through the gate, it can't come back. Stores in the battery, we use it. Through that little device that I just showed you, a little handheld device you carried around in the woods, in the fire zones, disasters, wars. Run your car, never have to put any gas in it. Solid state, simple, cheap. In 30 days we'd know whether this would do what it would do, and in 30 days we could be rolling these off the shelves. And instead we want to drill up in Alaska and collapse the whole tundra.